Assalamualaikum, sir. My name is Dana Batrisha, ID 18002463. For lab report fluid statics, I will present on hydrostatic pressure. For the introduction, hydrostatic pressure is the pressure exerted by a fluid at equilibrium due to the force of gravity. This fluid is called hydrostatic fluid. As for the center of pressure, it is a point on the immersed surface where the resultant hydrostatic pressure force acts. This lab was to determine the hydrostatic pressure of water on a flat surface, with the measurements of difference in the height of water in the tank and the weight required to balance the level. The calculation on hydrostatic force of the water can be done. The objective is to test the theory of hydrostatics for force and pressure center on a submerged plane surface. For the methodology, the first step is to dry everything on the balance arm, the weight tray, and the quadrant. Then, level the tank. Move the counterbalance weight until the balance arm is horizontally placed. After making sure the empty weight tray is in position, close the drain valve on the tank and start filling the tank until the water level reaches the bottom edge of the quadrant, until a meniscus is formed. Then, collect the first point for data collection. The second step is place a 50-gram mass on the weight tray. Add water to the tank until the balance arm returns to equilibrium. The third step is to record the height of the water level above the bottom of the submerged phase with the scale of the quadrant. Then record the mass in the weight tray. The fourth step is to repeat the measurement with 50-gram mass increment until it reaches the maximum water level reading on the quadrant scale. When the data collection for every mass increment is finished, drain the tank. This is the setup of the experiment. It mainly comprises of a rectangular transparent water tank, a quadrant, a balance arm, adjustable counterbalance weight, and a water level measuring. This is the results obtained from the experiment. 50-gram mass increment is added 8 times. Hydrostatic force, distance to center of pressure, and turning moment is measured. Distance to center of pressure is then calculated. These are the calculations used. For the discussion, the force applied in the system vertical phase of buoyant material counteracts the mass added. We know that by moving away from the sea level, the pressure will change either with air or water. In the experiment, there is change in pressure due to the weight of water above, and the buoyant force clearly shows the water properties. The water pressure was so high that the quadrant was still able to support it in static equilibrium after the increment of mass from 50 gram to 450 gram. This shows that the curved area allows for a larger surface which water can act upon for a less depth change. It explains the large jump in the force applied after breaking the upper plane of the vertical phase. In conclusion, hydrostatic pressure acting at the center of pressure counteracts the mass added. These two are directly related. The mass is the independent variable, so the level of water had to compensate for the mass. As the weight grew larger, the moment about the pivot increased. This results to the level of water to decrease, to create a longer moment arm for the hydrostatic pressure of water to counteract the force of weight. From the results, there were inconsistency between the theoretical and the experimental values of the center of pressure. It is found that the theoretical ones is lesser than experimental ones. This inconsistency may happen due to the procedures of the experiment. These are possible errors that might occur. First is neglecting the weights of the balance. Second is error in reading, such as parallax error in determining the touching point between the water surface and the pin of the measuring device. That is all from me. Thank you, sir.